Now let's talk about the formula to calculate the volume of a cylinder. For this, we have taken a circular ring which will act as the base of the cylinder. And this circular ring is so fine that it has almost negligible thickness. Here some thickness is visible, but it's because it has been drawn roughly. Okay. Now what you do is you keep on stacking this circular ring like this. Okay. The radius of one circular ring, the radius of one circular ring or the base is r. Therefore, the area of the base will be what? Pi r square. That is a radius, sorry, that is the area of a circle. Now, when you stack such rings together, and let's say that it attains a height h, it attains a height h. So don't you think that if the area of one fine circular ring is pi r square, that is, it covers this much space, pi r square, and if its height is now h, then the total space that this stack of circular rings will cover will be pi r square, that is the area of the base, multiplied by height. Again, the space covered by one circular ring is pi r square. Area means what? The space covered by a two-dimensional figure, right? So in this case, pi r square is the area covered by one circular ring. But if we go on stacking in a way that it attains a height h, now if someone asks you that what total space does this object occupy, then you will say that the total space will be actually pi r square, that is space occupied by 1. Now since we have height h, therefore pi r square h, where h is the height. So the formula to calculate the volume of a cylinder is pi r square h. In other way, area of the base, area of the circular base multiplied by height. This will be the formula to calculate the volume of a cylinder. Remember this. Now, this particular thing, that is the volume of this cylinder is equal to area of the circular base multiplied by height, is applicable in the case of cuboid and applicable in the case of cube as well. Let's see how. Here you have a rectangular, let's say rectangular plate, so fine that it has almost no thickness. Okay. In a similar way, you go on stacking and finally you get a cuboid like this. So if the area, let's say that this is the length and this is the breadth, the area of one rectangular plate will be, one fine rectangular plate will be what? Length multiplied by breadth, because this is a rectangle. Now when you go on stacking and it finally takes a shape of a complete cuboid whose height is actually let's say h, right? It takes height h. Now same what we have seen in the case of cylinder, the volume will be what? Volume will be area of the base, that is the space occupied by one fine rectangular plate multiplied by height h, that is L multiplied by B. Area of the base is L multiplied by B multiplied by h, and that is what we have learned. That is volume of a cuboid is given by length multiplied by breadth multiplied by height. This is the formula that we have been using from grade 6, right? So this is the way that we get this formula. Now let's see for cube. So this is a squared shape plate, so fine that it has almost negligible thickness. Okay, now let's say that its side is a, therefore this is a, every side will be a, right? Length will be a, breadth will also be a. Therefore area of this square plate will be what? a multiplied by a, that is a squared. Now if we go on stacking this square plate such that it attains a height of h. Now we know that in the case of a cube, h is actually again a, because all the sides in the case of cube are equal. All the edges are equal. Therefore, this will also be a. Therefore, if this is the height, so from the formula, volume is equal to area of the base, that is the space occupied by one square plate, area of the base multiplied by height, that is a squared multiplied by a. This becomes a cubed. And this is the formula we have been using from our grade 6. So the main thing is that you should remember volume of whether it is cylinder, a cube or cuboid. It's basically area of the base multiplied by its height.